Okay, this is your Chapter 7 final review. Today is Thursday, 2 days before Christmas break, and I know this stinks that you have to have a test on the day before Christmas break, but it's the only way we can make it work with... So the first 5 questions on your test are going to be true, false, and they have to do with differentiating between how you add and how you multiply polynomials. So for example, if I asked you this question, true or false, would the answer be true or would the answer be false? The answer for this is true, and the reason why is because when you have an x and an x and you add them together, the coefficient 2 is telling you how many x's there are. Conversely, if I gave you a question like this and said, is this true? The answer for this would be false. Multiplying an x by an x does not give you 2 x's. It would actually give you an x squared. Okay, so make sure you differentiate between what happens when you add x's and what happens when you multiply x's, because I will ask you a question like that on your test. Another type of question would be something like this. If I gave you 5x squared minus 10x divided by negative 5x, okay? And I asked you to tell me, will this simplify to be a, sorry, let's make that a positive x. And let's make this 5x2. Actually, let's change that out. Let's go like this. This is what I want to do. What if I gave you this question here and said, will this become a monomial, a binomial, or a trinomial when I simplify it? Okay. So the question you would have to do, here's the work you would have to show. You would first have to say, well, when I'm dividing a binomial, in this case the numerator, when I divide a binomial by the bottom number, another way to think of it, just if you want to, is 5x squared minus 5x. All of this divided by negative 5x. It's another way to think about it, right? We don't write it this way. We typically just write it like this. And when you do so, you have to remember that using distributive property, both terms in your top polynomial must be divided by negative 5x. So the first thing I would write is my first term divided by negative 5x. And then my second term divided by a negative 5x. Okay. In the first example, a negative 5 divided by a negative 5 is a negative 1. An x squared divided by an x is an x. So the first term would simplify to be negative 1x. And since you probably already know that I hate negative 1 coefficients, you would have to simply express it as negative x, which is the same thing as negative 1x. Now the tricky part comes here in the second question. A negative 5 and a negative 5 and an x and an x. Some people believe that when you divide a negative 5x by itself, a negative 5x, you get nothing. But in truth, you don't. You get the number 1. A negative 5 divided by negative 5 is a 1. An x divided by an x is a 1. So really what you end up getting is 1 times 1, which makes it a 1. And that's the important part, because some people think it's going to be 0. And that's actually a positive 1. So then when I squeeze those two things together, the simplification to this negative 5x squared minus 5x divided by negative 5x will be a binomial, negative x plus 1. So keep that in mind on your test. There are questions that are kind of tricky like that, and make sure that right here you don't think that a number divided by itself is 0. In the next question, if I was asking you for like terms, and I said to you ab squared c, and we'll go 2ab squared c and 2a squared bc, and I said, are these like terms? These are like terms because they share the same variables, a, b, and c, and this is a degree of 1, this is a degree of 2, this is a degree of 1, this is a degree of 1 and 1. They both share the same degree, which is 4. So I said, because they share the same degree and the same variables, they are like terms, true or false? The answer would be it's false, because not only do they have to have the same variables, but they also have to have the same amount of variables. So keep in mind that this is 2 times a times b times b times c, right? This one here. And this one here would be 2 times a times b times c, which when we write it out in terms of repeated multiplication, we can clearly see that they are not like terms, because although they have the same variables, they don't have the same amount of variables. So the answer for this would be false. In order for them to be like terms, they need to have the same variables as well as the same exponents attached to each of those variables. Degree has nothing to do with it. There are a couple other true and false questions that I won't get into, but as long as you understand those and can differentiate between those questions I have and know whether they're true or false, you should do okay with the 5 true false. The next questions on your test are all multiplication and division of monomials, which is from 7.1. So if you want to review 7.1, a question, for example, like 5x multiplied by negative 2x. This would be a question you would have. All right. Now, to show your work, you could say that really I'm going to multiply the 5 and the x and the negative 2 and the x, and you could rework it to be a 5 times a negative 2 times an x times an x. And when you take it from here to here to here, you can clearly see how you would multiply that to get the answer. 5 times a negative 2 would be a negative 10. So essentially we're multiplying our coefficients. And an x times an x is an x squared. So a 5x multiplied by a negative 2x will give you a negative 10x squared. And that would be the solution to this particular question. Likewise, if you had something like 10a multiplied by 10b, that's a monomial multiplied by a monomial. And in this case, again, just like before, you could go 10 times a times 10 times b, which would then be 10 times 10 times a times b. And 10 times 10 would give you that 100 coefficient. And then when you have an a times b, because they are not like terms, you can't use exponents to make it like a squared or a b squared. They have to simply remain as a times b. So we have the monomial of 100ab as the product of 10 times a times 10 times b. It's just simply 100 times a times b, or 100ab. Keep in mind, this means 100 multiplied by a multiplied by b. Since we don't know what a and b is, we can't change it, and we just have to keep it as the monomial 100ab. Similarly, when we have division of monomials, for example, 8xy divided by negative 2x, if this question was given to you, what I suggest you do if it's written like this is write it in a form that's more suitable to your eye, something that looks like this. For those of you who struggle with it. For those of you who don't, you don't need to. But since the red statement and the black statement are the same, most of us are used to seeing it structured the second way. So 8 divided by negative 2 will be 4 over negative 1, or negative 4 over 1. Notice how I switched my negative signs because I don't want my negative 1 in my denominator because I know it's not going to exist there anymore. X over x will become 1 over 1. And since I'm multiplying by 1 doesn't matter, so I'll just erase it, or I can put a 1 over 1 if you want, and a y. So what I end up with is negative 4 times 1 times y, which is going to be a negative 4y, over 1 times 1, which is 1. And since dividing by a 1 doesn't matter, we can erase it. And the solution to this division will simply be negative 4y. So again, when you have questions that are written linearly, restructure them so they're in a more suitable format so it's easier to kind of cross-reduce the fraction. Next thing you need to do from 7.2 is multiplication of monomials by binomials, or polynomials. So in this case, what if I gave you 8x multiplied by 2x squared minus 3x plus 1. Well, that's a trinomial, but whatever. In this case, you have to remember that when you multiply a polynomial by a monomial, you must use distributive property. So each of the terms inside the brackets must be multiplied by 8x. So to show your work, you would probably show 8x multiplied by 2x squared and 8x multiplied by negative 3x and 8x multiplied by 1. So the simplification of all three of these would be the solution to the product. So 8 times 2 is 16. X squared times x times x squared. If we use our exponent rules, keep the base and add the exponents, we will get x cubed. And again, if you want to think about y, you can write it over here. That's 8 times x times 2 times x, which would be 16 and 3 x's, therefore 16x cubed. This would be a negative 24x squared when we multiply the 8 and the negative 3 and the x by the x. And finally, the 8x times 1 is simply an 8x. Now, since there is no addition or subtraction sign there, we know that's a positive. That's going to become our operation sign between there. And our solution is going to be 18x cubed minus 24x squared plus 8x. So when you multiply 8x by all those things there, you end up with that. Okay, moving along. Sometimes you might see something like this, 10xy minus 2x divided by 2x. So again, we're seeing it like this. When you have it structured like that, reorganize your work. So it's this divided by this. Then you're going to use distributive property just like you would before with division. So 10xy divided by 2x. And you're going to have a negative 2x divided by a positive 2x. 10 over 2 is going to become 5. X over x cancels each other out, or become 1s, but it doesn't matter in the product. And y is left. Negative 2 over 2 becomes a negative 1. X over x becomes just a 1, or cancels each other out. So the solution to this division would be a binomial of 5y minus 1. Okay, so this question here, we have a fairly complex looking binomial that contained variables that we're not used to seeing, m's and n's, and we have a 5x. So for this particular question, it's probably best that you first put in your arrows to make sure you remember to multiply each of the terms in the binomial by 5x. The next thing I recommend doing, for those of you who struggle a little bit, is to rewrite the product of each of them like this. And if you would like, you can reorder the multiplication. Now here's the interesting part. When you have x's, m's, and n's, it's always best form, just like when we talked about descending degree of terms, you should always keep your variables in alphabetical order, even when, in this case here. So what I want to do is I want to put times an m, times an n squared, and times an x. I'm going to reorder it alphabetically. Okay. Same thing with over here. I'm going to go a 5 multiplied by a 4 multiplied by an m squared multiplied by an n multiplied by an x. And then when I finally simplify it, it's going to be 10 m n squared x plus 20 m squared n x. Okay. And you can't add those together because they are not like terms. Even though they do share similar variables, they don't share exact variable structure, so therefore you can't add them together. How many of you got that, by the way, just out of curiosity? Okay, good. That's a tough question. That's one of the tougher ones that you would see in terms of product. Next question. Let's try something like this. All right, what multiplication statement would this be saying? Oh, for this one here, what we have here is we have our monomial is 3x. And if we're looking at this as an area model, we're multiplying it by its length. Its length multiplied by its length, which is a 2x and an x squared. So the multiplication statement or expression that this is conveying is the multiplication of the monomial 3x by the binomial 2x plus an additional x squared of length. Now when we expand this using distributive property, we could do the same thing by multiplying each of the partial areas in here. So 3x multiplied by x squared. And when we did so, we would see this is a 6x squared, and this is a 3x cubed. So when we expanded it, this would be 6x squared and 3x cubed. Just a different way of modeling the expression or the multiplication of a monomial by a polynomial. Okay. Try this one. Hang on, not this one. Try this one right here. What if we did this, and did this, and did a 2, and a 4x, and a 3? What is this the multiplication of? So for this one, we have our monomial, which is just 3, and we're going to multiply it by the distance here, which is 2 and 4x. Now, some people want to feel like they have to change it to 4x plus 2, but because that's not what's modeled here, so your solution would be 6 plus 12x, and then if you want to reorganize your information, you can. You don't have to. That is the answer, and so is that. They're the identical answers. Okay. Also on your test, which I have now put down somewhere and don't know where it is, right here. Also on your test, I will give you a rectangle, and I will tell you its area. Area equals. I'll give you something like this. And then I will tell you that one of the measurements. And I will say, using your knowledge of multiplication and division of polynomials, what expression can you use to calculate the missing side? And, follow-up question, what is the perimeter? Okay, so go ahead and try that now. So with questions like this, it's always good to start with an easier question. So if this was area equals 10, and this was 2, with simpler numbers, I would know that the missing side length is 5, because 5 times 2 gave me the 10. But in terms of what operation would I use to get that, the area divided by the side I know will tell me the side I don't know. The same is true when we have polynomials. In this case, the area divided by the side we know will tell me the side I don't know. In this case, I have to use distributive property. 4x squared divided by 4x will simply be an x. A 4x divided by a 4x won't be nothing, it'll be 1. And therefore, your missing side length is x plus 1. And again, we could go backwards and just multiply the monomial by the binomial, and we'd still get the area 4x squared plus 4x. But the follow-up question says, what is the perimeter? And remember, perimeter is the addition of all the sides together. So since this is 4 sides, a 4x plus a 4x is 8x, 9x, 10x. 10x2 would be your perimeter. Remember, we have to go back in time to the previous chapter, which is adding and subtracting polynomials. So when you add together those terms, you have to collect them as if they were algebra tiles. Okay, another question you'll find in your test is something like this. You'll be given an area, and I'll give you the algebra tiles inside it. And I will give you something like this. And I will say, fill in the answer using algebra tiles, and rewrite this as a multiplication statement with its answer. Okay, so go ahead and try that, see how well you do. So in this particular case, what you have to do is, first of all, this is side length, this is side 1, and this is side 2. And the inside will actually express the product of the multiplication of these two. So all I have to do is just fill in the lines all the way down from where I am, and then fill in the lines all the way across, and then ask myself, are these going to be positive or negatives? Since this is a positive x and this is a negative x, this is going to end up being a negative x squared, and so are these ones here. Since this is a negative 1 and this is a negative x, these are all going to be positives. So I'm going to fill them in like this. And now I have my answer. So then when I reinterpret what the question actually was, it was a negative 2x, which is side A, my monomial, multiplied by my side B, which is 2x minus 4. And the product of those two is going to be the area inside, which is negative 4x squared plus 8x. Okay, so the solution would be filling it in appropriately like that for the 1 point, and then rewriting it again as the product of negative 2x multiplied by the binomial 2x minus 4 equals negative 4x plus 8x. Okay, does everyone understand that one? Do we want to try another one, or are we good? We're good. sorry. There are 3 more types of questions on your test, so I'm going to give you this one here. This one, I will give you one of the sides. I will then fill in something like this, and I will say, what is the statement this is modeling? What is the expression this is modeling? And what is the missing side? So fill in the missing side and write the equation that this question is expressing. Go ahead and figure it out. So the first part, which is worth your 1 point on your test, is to fill in the missing question mark. Since this is a negative x squared and this is a positive x, I know that up here I had to have a negative x in order to make the positive x multiply to give me a negative x squared. This is a negative x, a negative x, and a negative x. That's the only way I can multiply to get these algebra tiles that are modeled here. Then I have a positive x here and a positive here, so these have to be positive 1s in order for the product of a positive x and a 1 to be a positive x still. So the first part is to get that, and the second part would be to write this. Your area, which is negative 6x squared plus 6x, divided by the side I know, which is 2x, will equal the missing side, which is negative 3x plus 3. Okay, so you get 1 point for filling in the model correctly, and another point for writing the equation of division, as well as the solution as such. Another question you're going to have on your test is a triangle, and I will give you a base, for example, 8x plus 4, and I will give you a height of 2x, and I will say calculate the area of this triangle. Okay, calculate the area of this triangle. So the first thing you're going to have to do when you encounter a question with area is write a formula. So area equals base times height divided by 2. Base times height divided by 2. And the next thing you have to do is substitute. So your base is a binomial and your height is a monomial. And since it doesn't matter the order in which you multiply them, I'm going to flip things around and go height times base because it doesn't matter. And I'm going to write them as a monomial times a binomial divided by 2. Then I'm going to simplify this. That's going to be 16x squared plus 8x, half of that. And now we have a fairly simple division of a binomial by a monomial, because the monomial doesn't have any variables, just a 2. And we're going to take half of each of these. So half of 16x squared is going to be 8x squared, and half of 8x is going to be 4x. And the solution for the area of that triangle will be 8x squared plus 4x. And I can't add them together because they're not like terms. So the answer is the area of that triangle will be 8x squared plus 4x. Well, here's a variation question with area of circles. So if we consider pi to be 3, and I asked you the question, what is the circumference and area? So the circumference formula, you would first write circumference equals pi d. And then you would write down pi as being 3. And if you want to use 3.14 because you have calculators, that's a good idea. But if you don't have a calculator, 3 works because you can do it in your head. The diameter would be 6x. And sometimes we think it's 12x squared because we get our multiplication and our additions. But when I think about 6x as being x, 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 there's 6x there. There's another 6x. I clearly see that putting those two together does not make any x squareds. It simply makes 12x's. So since pi times 12x is going to be 3 times 12x, which is going to be a circumference of approximately 36x. That's the answer. For area, we can use pi r squared, or we're going to actually go back to the grade 7 formula of pi times r, which is the same thing as pi r squared. So once we write our formula, pi we're going to put as r multiplied by 6r times 6r. Okay, or the radius squared. So if I think about what the radius squared would be, technically we should do the radius squared first. So I'm going to do the radius squared. What is 6r times 6r? Well, it's going to be a 36r squared because it's 6 times 6 times r times r. And once we have that, we're going to have 108 as our coefficient multiplied by the r square. And therefore, the area of this circle would be approximately, since we rounded, roughly 108r squared. Sorry, not r, x. I made a mistake all the way through there, didn't I? 6x and 6x. My apologies. 6x and 6x, 6x squared, and 808x squared would be your area. And the last question that you might or will have on your test is something that involves fractions. So for example, 4/5 x multiplied by 1/2 x minus 3/8. So if you had a question like this, so this is distributive property, a grade 8 outcome, but instead of using simple terms, we're using x's here. So again, we're going to have to multiply these like this. So 4/5 multiplied by 1/2 multiplied by x multiplied by x. The product of 4/5 and 1/2, multiply the numerators to get 4, multiply the denominators to get 10. Reduce that to lowest terms, and you'll get 2/5 x squared. On the next part, 4/5 multiplied by negative 3/8 multiplied by x. If I multiply my numerators, I'll get negative 12, multiply my denominators, I get 40. Reduce that down to lowest terms, you'll get 6/20, which is going to be 3. 6/20 is going to be 3/10. So that's going to reduce to 3/10 x, or 3/10 x. That's it's going to be a negative. So the solution, since that's a negative, notice how the negative sign is here. That's just going to become my operational sign of subtraction. So the solution to this question would be 2/5 x squared minus 3/10 x. Okay, so hopefully that helps you guys with your review. If you can do all of those questions from the review, what I advise you all to do is watch the video again, write down the question, press pause, do the solution, see if you were right. If you were wrong, just kind of highlight the errors that you made, so hopefully on the test that you write tomorrow, you won't make those mistakes. But I'll guarantee you that every question I gave you will appear in some way, shape, or form on the actual test itself, just different numbers. Good luck.